Hello, welcome. In today's lesson, we will learn about two important topics of C language. One is the general structure followed by a C program, and the second one is data types. So what is structured programming language or structured programming? A programming paradigm which involves clarity, quality, and development time of a program, which is used for improvement, is known as structured programming. So structured programming makes use of extensive control flow constructs and helps in quick maintenance of the programs. The language becomes easy to modify and debug. Examples are C, C++, Java, Perl, Ruby, etc. So why is C called a structured programming language? Yes, C is a structured programming language because it follows a general structure in which the programs are written. It uses constructs like looping, branching, selection, etc. to make the job easy. So that's why this makes testing and maintaining and debugging process pretty easy. So the general structure followed by a C program is documentation section, linking section, definition section, global declaration section, main program section, and sub-program section. So in total, 6 sections. Inside the main program section, this is called as declaration section and executable section. The sub-program section is meant for defining user-defined functions, which we will see in the later part of the chapter. What does documentation section contain? So the documentation section contains comment lines, which are used to include the name of the programmer, details about the programmer, inputs taken, output expected, date and time, etc. Documentation section helps us to easily maintain and understand what the program is all about. There are two types of commands. One is single line commands, which is separated by a double slash, and the other one is multiple line commands. When you want to make multiple lines of commands, we use backslash star followed by multiple lines of comments and star slash. What does comments mean? Comments mean not considered by the machine, only for the user to understand. Comments are only for users understanding. So then goes to the next section that's called as linking section. Linking section is a place where we use a lot of predefined functions in our C program, which needs to be linked to the compiler or told to the compiler. So therefore, in the linking section, all the header files are included with a context, with the syntax hash include header file name in the angular brackets, hash include std.h, hash include corner.h, hash include stdlib.h, etc. Then moving on to the definition section, this is a place where the symbolic constants are defined. Symbolic constants are also known as macros. Example, hash define A10, hash define pi 3.142. In the fourth section, we talk about the global declaration section. Global is something that is freely available to all. Some of the variables that are used in more than one function throughout the program are called global variables, and they need to be freely available to all. So therefore, they are declared above the main. In this example case, consider x, which is defined above main function. So therefore, x becomes a global variable. This particular global declaration section also can declare user-defined functions that are available to all throughout the program. Then comes to the main program section. Any other thing that I have discussed in the earlier parts may be optional, but the main program section is must for any C program. The C program definitely requires only one main program from which the execution begins. Logically, main open brace is the place where execution begins, and with the closed brace of main function, the execution terminates. So it requires only one main function, and the name of the main function is only known to the compiler. So this contains two parts, the declaration part and the executable part. In the declaration part, you give declarations to all the local variables that we require for computation. And example, you write like int a comma b. They needs to be returned inside the particular open brace and closed brace of main function. Then moving on to the executable part. Executable part should contain at least one instruction that makes the computer work and give some output. So every instruction in C language is terminated with a semicolon. So all the statements must terminate with a semicolon. Whatever you write should be inside, in between the open and the closed brackets of main function. Many a times, it is not enough to get the job done with just the main function. You require so many more user-defined functions that help to serve your process a better one. So in that case, what we come across is a sub-program section where a lot of user-defined functions are defined in this particular area. Sub-program section falls under the main program section in the general structure of a C program, where we define all the user-defined functions. So for example, let us consider this program. In this program, There's no comments, we have omitted it. There is only one thing, hash include stdio.h, which is a linking section where you include your library file, library, standard library stdio, the header file. Then void main. Void is a return type which indicates nothing. Main is the name of the main function. Open bracket. Write your executable statement printf how are you. Here there are no declarations. Anything is omitted if it is not needed. But the only thing that's compulsory is at least one main program section and one executable statement, which is must. So you write it inside the open and close brackets of the main function where our execution stops at the close brace. So this is about the general structure followed by a C program. We now move ahead to look at various data types available in C. So how do you pursue a data type? Data type in C is used to indicate the type of data a program uses. So it determines the type of operations and methods also possible on that particular type of data. So a data type has a specific storage requirement. A data type has a specific format specifier. Each data type has a specific keyword and a specific range of values accepted by it. So data types in C are used to identify the variables that are declared. Did I declare it as a character? Did I declare it as an integer? Did I declare it as float, etc.? Also used to understand the return values of a function and also used to understand the inputs accepted by a function. Now, moving on to the types of data types, C primarily supports 4 types of data types. They are primary or fundamental or primitive or basic data type. The class 1 is primary, primitive, fundamental or basic. Class 2 is derived. Class 3 is user defined and class 4 is empty, that is void. So this is about the general classification. Fundamental, derived and user defined. Void, some people write it as part of fundamental. Some people also write it as the 4th data type. This is absolutely your wish. Let's move ahead and learn primary or fundamental data types. So the primary are integer, character, floating point, and double precision. These are the data types, and the keywords are int, char, float, and double. Each data type will have a format specifier as specified. For integer, it is percentile %d. For float, it is percentile %f. For character, it is percentile %c. For double, it is percentile %lf. So yes, this is what we are going to see. This is the range because every data type has a specific storage requirement, that is 4 bytes. According to the storage is the range. So therefore, this is the range on a 32-bit computer. These are the ranges. Character data type is used to store characters. They exist in 2 forms, signed and unsigned. Ranges of the character is -128 to 127. For unsigned, it is 0 to 255. Floating point integers, X point, Y type of numbers, which are stored in 32 bits, are called as floating point numbers. They exist in 2 forms, float with simple range and double with a broader range. Float accepts single precision, that is, it takes numbers up to 6 decimals, and double gives numbers up to 12 decimals. If we want to use something more than up to 12 decimal points, then there is something called as long double, which gives up to 14 points after decimal. So this is about. The next one is derived data types. Derived data types, as the name says, are the data types which are derived, which are extended from the primitive or fundamental data types. They are arrays, strings, pointers, and functions, which we will learn in detail about the next coming lessons. Next is user-defined data types. In C also supports users to define their own data types. Example structures, unions, enumerations, and type def, which enhances the readability of the language. Then comes the 4th data type, that's the void data type. Void is most understood when we talk about functions, because when a function is expected to return nothing, or void here means nothing. So when a function is expected to return nothing, we use something called as void. Then comes signed and unsigned. Signed and unsigned are called as type modifiers. Signed is used when you have a chance of taking both positive and negative values, and unsigned is usually used when you have only a chance of taking positive value. Long and short are type specifiers in C. If you want little more storage to what you already had, then you write long. If you want less storage than what you already had, if you know that your number is pretty small and do not require and do not want to waste memory, then you can keep it as short. Short works with int and char, and long works with long double and long int. So long A, if I write, implies that it is long int only. By default, you write long A, it becomes long int only. Long B implies long int B. Extend the storage, you use long and short. So this is about the data types. It's important for us to understand the general structure of the C program and also to learn about data types to ensure that we do write programs that are perfect. Thank you.